Hello everyone, my name is Ali-Ayman and I'm an electrical and electronics engineering student. On this channel, I do my best to help people ascend to higher levels of knowledge, understanding, and self-improvement. Right now, the videos are geared towards the knowledge side of the content, and it will initially be for IB and A-level students, but then I'll widen it for uni content and for other content, like finance. You can see all this in the channel description. This will be our second video on this series on atomic structure, which will hopefully form a much longer series on physical chemistry. Today we will be looking at mass number, atomic number, and isotopes. Now, let's start off with the atomic number. So, what is the atomic number? Well, the atomic number, quite simply, is just the number of protons in the nucleus of an atom. If you watched the previous video, you would know that protons are subatomic particles which are positively charged, and they are found inside the nucleus of an atom. Another subatomic particle which is found inside the nucleus of an atom is the neutron, which has no charge, and the nucleus of an atom is orbited by negatively charged electrons, and we'll look into the arrangement of these electrons in more detail in the upcoming videos. Another thing we mentioned in the previous video is that the overall charge of atoms is zero, and that's because the number of protons in an atom is equal to the number of electrons in an atom. So since the number of protons in an atom is equal to the number of electrons in an atom, since the overall charge of an atom is zero, this means that the atomic number is not only the number of protons in the nucleus of an atom, so not only does it tell us the number of protons, it also tells us the number of electrons in an atom, which is the same, as we said earlier, as the number of protons, more precisely, in the nucleus of an atom. Now let's look at the mass number. So the mass number is basically the number of protons and the number of neutrons in the nucleus of an atom. So the number of protons plus the number of neutrons which can be found in an atom. So we can rewrite this as number of protons plus the number of neutrons, which is the mass number. So another important thing to bear in mind is that the mass number of an atom is only determined by the nucleus of an atom, i.e. by the number of protons and the number of neutrons. The number of electrons has practically no effect on the mass number because the mass of electrons is very close to zero. They're almost weightless and therefore have practically no effect on the mass number for an atom of an element. So now let's look at isotopes. So what are isotopes? So isotopes refer to atoms with the same number of protons, but with different numbers of neutrons. So one thing to bear in mind is that atoms of the same element always have the same number of protons. That's a very important point. So what this means is that atoms of the same element may have different numbers of neutrons, but must always have the same number of protons. The number of protons never changes. So I can illustrate the concept of isotopes using carbon atoms. So carbon atoms have an atomic number of 6 and a mass number of 12. So let me show you, let me just draw out a carbon atom. So let me just draw out the main carbon atom first. So let's look at these two isotopes of carbon. So we've got carbon-12 here on one side and carbon-13 here on the other side. Let these circles just symbolize the nucleus of the respective atoms here. These outer circles here, they represent the shells of electrons. But for now, you can just ignore them because we're trying to explain the concept of isotopes. So the The outer electrons for now can be ignored. You can see in both carbon-12 and carbon-13 that the number of protons in both nuclei is the same. You've got 1, 2, 3, 4, 5, 6 protons here, and 1, 2, 3, 4, 5, 6 protons there. But the number of neutrons, these empty circles represent neutrons, and these circles with a red cross represent protons. Apologies for the poor drawing. The number of neutrons here is 6, 1, 2, 3, 4, 5, 6, and then the number of neutrons here is 7, 1, 2, 3, 4, 5, 6, 7. So the number of neutrons is different in both carbon-12 and in carbon-13. So this makes carbon-12 and carbon-13 isotopes of each other because although they have the same number of protons, their number of neutrons differ. A very common means of notation we use when trying to write down or represent elements alongside their mass numbers and their atomic numbers is this, the AZX. So essentially, X represents the chemical symbol of the element. So for chlorine, that would be capital C, lowercase l. For potassium, that would be a capital K. For sodium, that would be a capital N and a lowercase a. Again, you can find all the chemical symbols on the periodic table. The A represents the mass number of a particular atom of an element, and the mass number, as we said here, is equal to the number of protons plus the number of neutrons in an atom. And then Z represents the number of protons that can be found in the nucleus of an atom. So Z is basically the atomic number. And one last thing I forgot to mention is that the atomic number is also known as the proton number. So if you hear the phrase proton number being used instead of the atomic number, just know that it means the exact same thing as the atomic number, which is the number of protons in the nucleus of an atom. Now, for the last thing we're going to be looking at is this question here. So why do isotopes have similar chemical properties? Well, before I write down the answer here, let me redraw those carbon atoms we had above, but this time without the nuclei, this time just with the outer electrons. So here are the two isotopes from above, carbon-12 and carbon-13. Now there's a number of things to keep in mind. Number one, the atomic number of carbon is always 6. So carbon always has an atomic number of 6 or 6 protons, whichever isotope. So carbon-13 will also have 6 protons. If carbon-12 and carbon-13 have 6 protons, since we know that both isotopes are not electrically charged, they're neutral overall, they must both also have 6 electrons. And we'll talk more about the arrangement of electrons, but it's very useful to always keep in mind. I will expand on this in the next video, but so since carbon atoms have 6 electrons, the first two fill the first, what we call main energy level, or the first shell. And then the next 4 fill in the second energy level, or the second shell. And the same applies for the carbon-13 isotope. But what matters in both cases is the outer electrons. The number of outer electrons in both cases is 4. And what determines the chemical properties of an element or of an atom is entirely down to the number of outer electrons the atom of that particular element has. In this case, both isotopes have the same number of outer electrons, and as a result, they have similar chemical properties. And one last thing is the number of outer electrons. When we refer to the number of outer electrons, we can also just call it the electron configuration. Both terms are equally correct. And one other thing, so if we want to find the number of neutrons, because usually when we have an element represented in this notation where we have the chemical symbol, the mass number, and the atomic number, to derive the number of protons in atoms of a particular element, that can just be read off from Z, the atomic number. So Z gives us the number of protons, so it tells us the number of protons in the nucleus of an atom, and as we said before, it also tells us the number of electrons which orbit the nucleus of an atom. And we're also given the mass number A, which is the number of protons plus the number of neutrons. So if we wanted to find the number of neutrons would equal the mass number minus the number of protons. In other words, the number of neutrons would be equal to A minus Z. So that's how we would obtain the number of neutrons. So now let's look at some summary questions. I would like you now to pause the video and attempt these questions using what you've learned from this video and in the previous video. Once you finish, you can resume the video and compare your answers with the ones I'm about to present shortly. Right then, so let's read the question. So isotopes are usually identified by the name of the element and the mass number of the isotope, as in carbon-13. However, isotopes of hydrogen have their own names. Hydrogen-2 is often called deuterium and hydrogen-3 tritium. However, both these isotopes behave chemically just like the most common isotope, hydrogen-1. State how many protons, neutrons, and electrons the atoms of the following have. So for deuterium and for tritium. Well, the first thing I want to highlight is the matter of this -2 and -3 and before carbon-31. So basically what that means is for this one, so hydrogen-2, that literally means we're looking at an isotope of hydrogen which has a mass number of 2. So its number of protons plus its number of neutrons is equal to 2. What I mean by that in this case is that this isotope of hydrogen not only has 1 proton, but it has 1 proton in addition to 1 neutron. That makes it an isotope of the original atom of hydrogen, which only has 1 proton. So the question has asked us to state how many protons, neutrons, and electrons these atoms have. So let's start off with deuterium. So using the periodic table and using what we said before, we said that isotopes of an element always have the same number of protons. So it doesn't matter which isotope of hydrogen we have here, we can always, read off the atomic number from the periodic table. And doing so gives us an answer of 1, because the atomic number of any hydrogen atom is always 1. So number of protons is equal to 1. And the number of electrons is also equal to 1. Because isotopes, just like atoms, have no charge. So the number of protons in their nucleus must be equal to the number of electrons that orbit their nucleus. And now the number of neutrons as we said before, is equal to the mass number minus the atomic number. So in the case of deuterium, the mass number, as we can see here, the mass number is 2. So we have to do 2 minus the atomic number, and we've said that we've said that the answer to that is 1. So the number of neutrons is equal to 2 minus 1, and the answer to that is just 1. In case it wasn't clear, both deuterium and tritium are isotopes of normal hydrogen atoms, which you can see from the question. So the number of protons in tritium is also 1. because the number of protons never changes when we look at atoms or isotopes of the same element. Number of electrons is also equal to 1 because isotopes are always uncharged. And now the number of neutrons, well, that'll be equal to the mass number, which is 3, as you can see here. The number of neutrons is equal to 3 minus the atomic number, which is 1, and the answer to that is 2. So question 2 asks us, identify which of these atoms, it makes it clear that these are not their real symbols, but it asks, identify which of these atoms is a pair of isotopes. So what did we say were the conditions for two atoms to be a pair of isotopes? We said that this condition is that they must have the same atomic number, in other words, the same number of protons. So the atoms we can see here which have the same atomic number, again, in the notation we used above, that would be the Z equivalent. This would be the A equivalent, and here's the chemical symbol. So to find the atoms which have the same atomic number, we have to find the atoms which have the same number of protons, which can be shown in these numbers at the bottom, and that would be X and Z. So X and Z are a pair of isotopes. And obviously they have different mass numbers, i.e. different numbers of neutrons, and that's another condition for them to be isotopes. Okay, so question 3 wants us to state the number of protons, the mass number, and the number of neutrons in each element in question 2. So let's start off with W. It wants us to find the number of protons in W. So we can read that from the atomic number here, which is 15. So the number of protons is also 15. We also have to find the mass number, and the mass number can be read from the number here at the top, which is 31. So the mass number is equal to 31. And then the number of neutrons is found by performing mass number minus atomic number. So number of neutrons is basically equal to 31 minus 15, which is equal to 16. And that's the number of neutrons in the atom W. So for question 3a, the number of protons in X can be read here. This is the atomic number, and the answer to that is 7. The number of protons is 7. The mass number of X is equal to the number here at the top, and that's 14. And the number of neutrons, like before, is equal to the mass number minus the atomic number, or the number of protons, and number of neutrons is equal to 7. And now for why the number of protons can be read from here. 8 is the atomic number, so the number of protons for Y is equal to 8. The mass number of Y can be read from this top number here, the A equivalent as we mentioned before, and so the mass number is 16. And then the number of neutrons is equal to the mass number minus the atomic number, which is 16 minus 8, and that's equal to 8. Now for Z, the number of protons can be read here, the Z equivalent, which is 7. And then the mass number of Z can be read from this top number here, which is 15. So the mass number is 15. And then the number of neutrons is equal to the mass number minus the atomic number, which is equal to 15 minus 7. And the answer to that is 8. And that's the final answer. And these are all the answers for these summary questions. Check them, make sure you got them right. Now, this is the end of the video. I hope you enjoyed this video and you learned some new things. Be sure to check out the resources I'll put in the description. Watch the previous videos. If you like content like this, please like, share, and subscribe. And I will catch you in the next video. Goodbye.